So as with set operations, the changes are more going to be in complexity for Venn diagrams than in terms of actual content and approach, although we add a little bit more to deal with the fact that we have a little bit more to work with. Let's take an example here. What we're given is the Venn diagram there with 3 regions, and our goal is to look at the picture we're given and be able to identify certain unions and intersections, namely A union B union C, whole thing complement, along with A complement intersect B complement intersect C complement in terms of the regions graph. So what we want to do here is dig through what that picture actually tells us in terms of the regions, where if we want to find A union B union C on that, what we're looking at is essentially the overlap of all of our circles all put together. So that would be every region except for 8, obviously, because 8's what's outside. And then because we're looking at a complement, we want what's outside. So using that diagram, hopefully we can pretty quickly tell that A union B union C complement. This is kind of terrible notation to write it this way, but we can essentially say this as being say 1 through 6 complement, which ends up just being the region 7. Excuse me, 1 through 7 ends up being the region 8. Bad counting. On the other hand, if we look at all of them intersected, all the complements intersected, so A complement is everything but that circle. That circle includes bits of B and C, where if we look at A complement, we're getting the outside of the circle, B complement, outside of its circle, C complement is outside of its circle. The only thing that overlaps between all of them is the outside again. So A complement intersect B complement intersect C complement is actually the same as A union B union C complement. This is a bit of an idea that we'll look at more at the end of the section, this idea of proving relationships using Venn diagrams, but this hints again at that thing we talked about near the end of section 2.3 called De Morgan's Law. It's a very important set of rules that we have to work with for set algebra. We'll see more on that later.